Have you ever stopped to think about the magic that happens when you flip a switch? A room that was dark is suddenly filled with light. You plug in your phone, and a tiny battery starts to fill up with energy. This invisible force is electricity, and it is the lifeblood of our modern world. It is flowing all around us, all the time, through wires hidden in our walls and inside every single gadget we own. From the television that brings us stories to the refrigerator that keeps our food fresh, electricity is always at work, making our lives easier and more connected. It is so common that we often forget it is even there until the power goes out. Of course, understanding this force is not just for scientists or engineers. In fact, knowing the basics of electricity can be very useful for everyone. It helps us use our devices better, understand why some chargers work faster than others, and most importantly, it teaches us how to be safe. When you know what is happening inside the wires, you can make smarter choices. This knowledge can help you fix small problems, choose the right equipment, and avoid dangerous situations. Think of it like learning the rules of the road before driving a car. Understanding electricity is about learning the rules for the electronic world we live in. This journey into electricity starts with three main characters: voltage, current, and power. These three concepts are the fundamental building blocks of every electrical circuit. Imagine them as a team that works together to get a job done. If you have ever wondered why a small battery can power a toy car but not a big fan, the answer lies in understanding the relationship between these three things. They are the A, B, and C of electronics. By learning about each one and how they interact, the mysterious world of circuits and gadgets will start to make a lot more sense, and you will see your everyday devices in a completely new light. So let's pull back the curtain and look at what is really going on. We will not use complicated maths or confusing jargon. Instead, we will use simple comparisons to things we see every day, like water flowing through a garden pipe. This will help us build a clear picture in our minds. By the end of our discussion, you will have a solid foundation. You will understand what those numbers on your phone charger mean, and why it is important to use the correct one. Let us begin this simple, safe, and illuminating exploration into the very basics of electricity. It is easier than you think. Let's start with voltage. Think of a big water tank placed high up on a building. The height of the water in the tank creates pressure. If you connect a pipe to the bottom of this tank, the water will want to rush out because of this pressure. Voltage is like that water pressure. It is the electrical push or force that gets the electricity ready to move. It does not move anything on its own, but it creates the potential for movement. A battery is like a small personal water tank. A 1.5-volt battery has a small amount of push, while a 9-volt battery has a much stronger push. This is why we measure voltage in units called volts. Now, if voltage is the push, what is actually moving? That is where current comes in. Let us go back to our water tank and pipe. When you open the valve, water starts to flow through the pipe. This flow of water is just like electrical current. Current is the actual movement or flow of tiny electrical charges through a wire. The more charges that flow past a point each second, the higher the current. We measure current in a unit called amperes or amps. A thin wire is like a narrow pipe. It can only let a small amount of water or current flow through it. A thick wire is like a wide pipe, allowing a much larger current to flow easily. It is very important to see that voltage and current are two different things, but they work together. You cannot have a flow of water or current without pressure or voltage to push it. Similarly, you cannot have an electrical current without voltage. Imagine our water tank again. If the tank is nearly empty, the pressure is low, and the water will only trickle out of the pipe, even if the pipe is wide open. This is like a battery that is running out of power. Its voltage drops, so it cannot push enough current to make your torch light up brightly anymore. Let us look at a real-world example. Your phone charger might say 5V on it. This means it provides a steady electrical pressure of 5 volts. When you plug your phone in, the charger pushes a current through the cable to fill up your battery. The amount of current might be 1 amp or 2 amps. A 2-amp charger is like a wider pipe, letting more current flow in the same amount of time, which is why it can charge your phone faster than a 1-amp charger. Understanding both the push, which is voltage, and the flow, which is current, is the first big step to understanding any electronic device you use. We have talked about the push, which is voltage, and the flow, which is current. But what about the actual work being done? This is where our third character, power, enters the story. Power is the rate at which electrical energy is used to do something useful, like creating light, producing sound, or making something move. If voltage is the pressure of the water, and current is the flow rate of the water, then power is the total force of that water hitting a water wheel and making it spin. Power is the combination of both the push and the flow working together to get a job done. The relationship between these three is beautifully simple. To find out the power, you just multiply the voltage by the current. The unit for measuring power is the watt, named after James Watt, a pioneer of the Industrial Revolution. So, the formula is power in watts equals voltage in volts times current in amps. Let's take our phone charger example again. If a charger provides 5 volts, which is the push, and delivers 2 amps, which is the flow, the power it is supplying is 5 volts times 2 amps, which equals 10 watts. This is why you see numbers like 20-watt fast charger, or 65-watt laptop charger. A higher watt number means the device can deliver energy much faster. This concept helps explain why different devices need different amounts of power. A small LED nightlight might only need 1 watt of power to glow. It does not need a strong push or a heavy flow. However, a big electric heater needs to generate a lot of heat, so it might use 2000 watts. It requires a very large amount of power, which means it draws a lot of current from the high-voltage wall socket in your home. This is also why running an electric heater costs more on your electricity bill than running a tiny nightlight. It is using up energy at a much faster rate. A quick historical fact: the units we use are named after early scientists. The volt is named after Alessandro Volta, who invented the first chemical battery. The ampere is named after André-Marie Ampère, known as the father of electrodynamics. And as we mentioned, the watt is named after James Watt. These naming conventions honor the pioneers whose incredible work allowed us to understand and control the electrical forces that power our modern lives. Their discoveries laid the groundwork for every single electronic device we rely on today, from the simple light bulb to the complex computer. Now that we know the basics, let us talk about safety. Electricity is a powerful servant, but it can be a dangerous master. The most important rule is to have a deep respect for the electricity that comes from the wall sockets in your home. The voltage in India is typically 230 volts, which is very high and can be extremely dangerous, even fatal. Never ever poke anything into an electrical socket, and always make sure your hands are dry when you are handling plugs and switches. Water is a good conductor of electricity, and mixing water with electricity is a recipe for disaster. When it comes to your gadgets, always try to use the charger that came with the device, or one from a reputable brand. A cheap, poorly made charger might not regulate the voltage and current properly. This can not only damage your device's battery over time, but also poses a serious fire risk. If you notice a charger getting unusually hot, making a buzzing sound, or if the cable is frayed or broken, stop using it immediately. It is much cheaper to replace a faulty cable or charger than to replace your expensive phone or, worse, deal with a fire. Understanding these basics also helps you become a smarter consumer. When you buy a power bank, you will know that one with a higher milliamp hours, or mAh, and a higher watt output will charge your devices faster and for longer. When you are choosing LED bulbs, you will understand that a 9-watt bulb gives the same amount of light as an old 60-watt incandescent bulb, but uses far less power, saving you money on your electricity bill. This knowledge empowers you to make informed decisions that are good for both your pocket and the planet. Finally, if you ever need to do any electrical work at home, like changing a switch or a light fitting, always turn off the main power supply first at the circuit breaker box. If you are not 100% confident about what you are doing, it is always best to call a qualified electrician. There is no shame in asking for professional help when it comes to electrical safety. By following these simple tips and using your newfound knowledge of voltage, current, and power, you can continue to enjoy all the benefits of our electronic world safely and smartly.
For more electronics videos, subscribe to Rise with Technology.